all the Europe is supervised by this national organization that regulate all the civil aviation. It is an authority that delivers authorizations and make laws, and so you have always to go and connect to the site and to read all the new rules, etc. Okay, so and you need to have an authorization as pilot, and I think that it's the same thing in all other countries where they're taking into account the drones. So just to say that LENAC is the structure that governs and supervises all what we do in the civil aviation and the drones. Okay, it is very important when I told you that selecting the right engine for flight is very important, and this mainly depends on the zone that you want to cover, and also about the resolution that you want to reach, the accuracy. As you can see, a multicopter here can cover small zones, and the autonomy of the batteries is very low. So for the same resolution, as you can see, a drone for a 1.2 centimeter resolution at ground, GSD is the ground sampling distance. It's the distance between 2 pixels. For the same resolution, you see that the drone has to fly at 44 meters. The fixed wing has to fly at this distance because they have different payload and camera quality and so on. So if you want to cover a small distances, like a small archaeological site, a drone multicopter is enough to do the job. And when the distances become bigger and larger, you need to have a different kind of engines. Okay, in this kind, the right one, it's a fixed wing and eVTOL. It means that electric vertical takeoff and landing. These kind of drones can take off vertically. So it's very important for safety, and because they are very difficult to take off and to land. You need the very big space and area with clean area to make this engine landing. So as you can see, the kind of drone is a response for the zone that you want to cover and the kind of resolution that you want to reach. As you can see, the UAV fixed wings, even it covers large zones. He has some problems because this kind of engine are always on move. It's not like a drone that you can hover and you can wait for you since you don't give him an instruction. He will wait for you by hovering operation. But this kind of engine, they're always moving, and they have no hovering operation, and it's more difficult to pilot. The problem of this machine is that you will pilot in BVLOS technique beyond the visual line of sight, because you will send it very far and you will lose it from your visualization. You need a special qualification. You need a special authorization to make such flight, and also they are quite expensive. Okay, because the payload on this kind of machine are very expensive. They are a camera of very high quality, and they present also landing problems. You need the big surface to make it landing, and they have also very expensive cameras. You have to take care about how you will land this machine. That's why they have some negative points. For the drone, for example, it's a little bit different because the unique problem is the autonomy, because the batteries are not. It's really due to the physical construction. They have more motors, and it needs to hover instead of flying. Okay, natural flying of the wings. But it has this opportunity that it is safety, because it gives you the opportunity of hovering. Okay, so you can use it safely. Okay, so this is a kind of mission that you can plan with the drone. Okay, and this is how you obtain the images. Okay, georeferenced images. So let's talk about data quality. Now we talked about drones. Now we will talk about the data quality and what are the pieces that will be very important for the data quality. First of all, the camera, because we are producing images. What we need of quality is the camera, okay, on board. And the camera itself, you have thousands and thousands of type of cameras. But what you have to take care is about the sensor resolution, the CCD or another technology. The lens also, you need to know if the lens are of high quality, the type of the lens, okay, and also the type of the shooter, because you can have a software shooter, you can have the hardware shooter. So you have to take care about the quality. But the price will decide. They are very expensive. The good camera is very expensive, so this can be a determinant in the selection of the camera. The other piece that will decide on the resolution of the quality of the data is the gimbal itself. You know that the camera is mounted on a gimbal, which is a three-dimensional machine that will fix the camera. Even the camera moves. Okay, the drone will have this gimbal that will have micro displacement motors that will always keep the camera pointing the same point. So even you have the wind or the drone is a little bit not stable, the drone will take care of stabilizing the image. Okay, so this is very important. If you don't have a good gimbal, the images can be out of focus, you can have blurred images, and so on. The other aspect is to take care about the weather, because if you fly in a windy day, as I told you, you will compromise your data quality. And also the light condition. You can fly in the night if it's not a thermal camera. So if you don't have enough light, this is the secret of images, the light. The light is poor, the images will be poor, and you will have noisy images, and the software we go crazy to make the 3D models or whatever you want. So I can show you now. After you decided all this and you have a good drone, you can begin to plan, even in the laboratory, your mission. Okay. So the missions are planned with the ground station software that is provided by the constructor, usually, or you can use a third-party software that can give you the possibility to have maybe more parameters to control your fly, if it's a special fly or you need to do particular things and so on. So the ground station, we used to call this kind of software as ground station, because you are on the ground and you can plan using Google Maps or so on, you're flying. Okay, so I can show you here in this is movie a real time. I don't know if you see the movie.
Yes, we can see.
Okay. So here the drone is transmitting in real time on the coast. In real time, you see the drone flying. And now I will point if you can see on the sky the drone. It's difficult, but the drone is now here. And now you can see that he's following the lines that we decided that they are the fly plan. Okay. And he takes pictures all along these lines, and then we will use. Here he's taking the pictures. It's almost finished. Maybe some of you already used a drone. Okay, so this is the first part is planning the flight and then executing and running the flight plan to produce the images that you will later use in the laboratory and to make your products. Okay, so there's another problem. Let's say it's a problem. You know that the drone has an GPS, an onboard GPS. The onboard GPS is very important for all for many aspects. It is important for positioning the itself. Okay, he needs to know where is his position in that time, because the first versions of the drones didn't have a GPS. They were always deriving and shifting, and they only use a barometer to know at what altitude more or less they are, relative altitude from the ground level. And then when the GPS became small and miniaturized, the drones become to have a GPS on board. So the GPS is very important for the positioning, okay? And then I will tell you for other things, not only for its own positioning. For the hovering, because sometimes you need to make the drone hovering, so he needs to know where it is, and then he keep this position. The GPS is important because it helps the drone to go back home, because if you send it somewhere, he needs to back. So he memorized the position of the home, and then he can come back for landing. And now we have also the GPS on the radio control. So the GPS the drone knows that where is the position of the pilot, because on the radio there's a GPS also. So this is very, very important. And at the end, the GPS is very important for the navigation. As I showed you before, he needs to know where to go and which direction and so on. So it's very important for the navigation. Very important. The GPS is important for geolocalizing the images. So every picture, when it's taken by the drone, needs to be geotagged, as we say. So every center of the image has a coordinate. Okay, so this is very important. But we will see that this position is not great. We have a problem with the XY, okay, the position on the plan, and we have another big problem is the Z, is the altitude. The GPS of the drones are not very precise. They have a metric, not centimetric, but metric errors. So the images are not very well localized. That's why I will talk about how to work on the ground to improve the positioning. Okay, so the GPS is a big invention for drones. So now we will talk about the ground control point, because you fly, but you need to make your images very, very precise. So that's why we have a GCP deployment on the soil. We do it before flying. We put some marks, as you can see in the images, on the soil. Sometimes they are physical targets that we print, or we go and do it by hand with some paint. Okay, so the GCPs are clearly visible. They need to be clearly visible in correspondence on the altitude that we select. You can't use a small points if you fly at 120 meters. You will see anything. So that's why you need to have enough visible targets on the soil. Okay, so these points have to be very visible on the ground, and we will measure these points with a special GPS that we call RTK, with a real-time kinematic GPS that makes a correction in real time. Because this GPS needs to be connected to internet and to connect to a GPS network that makes the correction in the real time. This is very important because we will use all this data to correct all our images that we produced with the drone. So as you can see, this is the hard work on the ground. This is Marco making some marks, and don't worry, this kind of paint is ecologic. So this is I don't know how to say, biodegradable, maybe, because it's not toxic. So we use this kind of paints that after the rain and it will be cleaned. Okay, and so we make these marks and use the GPS, as you can see in the bottom. We have this very compact RTK GPS that will measure a precise point in the three directions, X, Y, and Z. And these markers has to be in the pictures. We have to find them on the pictures on the drone, so it will georeference them. So as you can see, this is a kind of ground control points that has been made in Vasiliki in the framework of the project of SAVEMEDCOASTS. Okay, you will always see the sea and the coastline because all the project is around the sea and the sea level, right? Okay, sometimes we put also signs with the spray. Okay. This is another type of image that shows if you can see here, the blue crosses are the GCPs, okay, the ground control points, and these red dots are all the images that cover the zone. So you need to have more points you have, better is. Okay. So here the Greek colleagues obtained a DM of 4 centimeters. You can dream it with other solutions. Okay, these are another images from a drone. Okay, so if I can summarize all this part, it's a real strategy to make a fly. Okay, if you want to be to have good results and to be wise, because it's not an easy thing to do. It's a serious operation because you will occupy IRL space for a while, and you know, to make a fly, it's also a mission. So the government pay the mission, and so if you don't bring back quality data, all this is spoiled money. Okay, so you can see is we have a phase that we plan in the laboratory, and then on the ground in the field work, and then we have all the processing part in the laboratory that we show you. So this is the second phase that now I can certify that we can do it even in the hotel, because now the computers are so strong that you can decide if you can if you have to do again your fly, or to go back to the laboratory and launch the serious run the serious processing. So in the laboratory we will we need computing power and performance, very good processors, large amount of RAM, of memory. You need a professional software, because sometimes you find software and open source software that's not very serious. And we use professional software because you have a commercial service, and people reply to your mails, and it's very important to have a serious professional software. When you make your computer, you need also a GPU, which is a graphical processing unit. This GPU, it's the processor of the graphical card. It's not another thing, but they are constructed to be very fast to process graphical aspects. So it will help the processor of your computer. And sometime you will process thousands of images, and the beginning of the history of photogrammetry, some processing can last something like 2 or 3 days, even more. But with the new technologies now, you can do it in the longest period. Okay, it's 1 day. It depends on how many images you have. So you can project your computer to reduce the time of processing, because it's very important to know if you made a good fly, or you have to do it again. That's a problem. So what you need is a large storage also, because you will not produce only images, but all the intermediate results will consume a large amount of storage. So you need disks and so on. And if possible, take a fast storage. It's solid state disks that are very fast, because you need a short time of input-output aspect during the processing. So I can also tell you that during the COVID period, the smart working helped us to never stop working, because using a remote desktop, if you have a good processor, you can do your job from home. So a good computer helps you to do the job even in a very difficult situation. Okay, so for the photogrammetry in the laboratory, the first phase is to preparing your images. You have to see if all the images are well exposed, if you have a good focus, and you can intervene a little bit on the quality of the image, but never change the dimension of the images or crop them. Or you have to keep them as the drone took them. In the generation of the models, the first operation is the image alignments. So using the GPS of the first GPS of the drone, the software will position all the images in their place, and will produce a first cloud of very sparse points. After that, you can generate the first cloud. It's a point cloud. It's around 1,001 million points. It depends on how many images you have. So then you can use the software to produce the cloud densification, which is after correcting all the errors. There are procedures to correcting errors and the crazy points around the model. You can go ahead and produce the cloud, the dense cloud, which is more than 1 million points. And this will be the base of constructing the 3D model, okay? So after densifying, you will generate a 3D model, as you can see here, okay? And this is the first operation. And then what you can have is the mesh of the 3D mesh of the model, and then you can use all the images to texture to drape your images on the model. Okay. So this is a kind of product that you can obtain. This is a shaded relief from a DM or DTM or DSM. There are three different notions. Okay. Later, maybe I can explain if you want. I just want to. Okay. This is also an important product, which is the orthomosaic or the orthophoto. So using the 3D model, we will be able to mosaic all the images and to make a large, big image of all the scene, which is auto-corrected. It means that distance and angles are preserved, and you lose all the 3D dimensions. It is a projected image on the plane. And usually it is very, very important for people that want to work on the field and make engineering aspect and so on. So this is an example of projection of the line cost. As you can see here in red, maybe Marco showed you this as a result yesterday. And this is what we can obtain from the DEM. So interpolating or extracting the zero altitude line. Another product is the profiles that we can obtain from the cost lines. Okay. Using the DEM. I show you very quickly, because I have almost finished, an example of works also on the seismotectonic fields. For example, here I flew on a trench, a very long paleoseismological trench, that it can be very, very useful for people to geolocalize the work and so on, and to see the trench and the fault. And this is a smart photogrammetry. I call it smart photogrammetry because we have been able to produce DEMs and 3D models from ancient aerial photos. So if you have a coverage, an old coverage, so you can generate a DM and an orthomosaic using the software to have maybe an ancient configuration of the topography or of the urbanization and so on. So this is an image from the 1950. This is also photogrammetry in the field of cultural heritage and archaeology. It's very, very often used now. So in conclusion, I can say that the ultra high resolution mapping is very possible using drones. Drone is a valid solution and reasonable economic solution, because I don't want to say low cost, but it's very reasonable to be held by a laboratory. The UAV imagery processing demonstrate an accuracy of about 2 or 4 centimeters, and this is very, very important, because this is the scale that people ask for. And the drones help you to do it by yourself as good as you want. You can reduce the resolution, fly higher, fly a little bit lower to produce a very high resolution. An ultra high resolution DM produced by processing imagery can help an SLR, okay, the sea level rising threats, for short time scenarios. What this means? You can fly when you want. You can fly when you want, as frequently as you want. So you can follow maybe the evolution of the phenomenon, but not only this, because if you fly for 20 years, you can leave for the future generation, images that they can find in the future. So they have a comparison images. Okay, so the orthophoto produced are very important because they are cartographic support for the project. So this is my conclusion on this kind of work. It's just a joke, because it is strange to look so high when the problem is so low. drones often drive people crazy because the problem is in the sea and we're looking always at the drone. The last one is just to make people taking care about what they do. You have the control, so you always, when you fly, take care about the other people and be wise, and don't fly when you don't need to fly. This is the very important, because sometimes when you don't to fly, you just want, oh, let's make a later flight, and the accident arrive. That's why this is my advice, and thank you.
Thank you very much. It's very nice, interesting talk. As you mentioned, it is the technical part which clarify more the talk which was presented by Marco yesterday. As you mentioned, drone and all of the photogrammetry tools is largely used actually in the different aspect of the geologies, as you presented, for example, in morphotectonics, paleoseismology, geoarchaeology as well. So just as a technical simple question, in regards to your experience, in comparison between, for example, XB drone and other with the other kinds, XB seems more compatible and user-friendly concerning to them, because with the XB, as I know, we can use it manually easily and doesn't need really pilotage, very expensive pilotage. It's correct or not?
No, it's right. It's right. The problem, it depends on the country and the norms and the regulation, and okay, it's very easy, it's only you need to move it. The accelerometer knows that you want to launch it, to run it, and it becomes to run, okay, and you launch it. And if you have a fly mission, it will do everything by itself, so it will follow it's in some aspects it's better than a drone, because it can cover very large zones with the same resolution, even better. So this is I think if you're talking about Iran, because I know a little bit about maybe Iran, you have very large zones that you can fly, I think, on more or less desertic zones, if I'm not wrong. And if you don't have problems with authorities, it's better to use the XB. In some zones we can't use it because it's no-fly zone, and you need the special permits. I told you, BVLOS authorizations, and that's why it's very crazy to go to fly with a drone. That you have to call it back, to change the battery, to launch it back, and to count back. The XB is a very good solution when you can to fly freely, let's say.
For a subject, say, for example, pipeline, which drone could be more user-friendly?
For a
pipeline, we should switch from the one base to other base. I think XB can use in the serving of the pipeline or not?
Yes. What you want to say about base?
For example, because for all of the drone, we have a limitation regards to the energy.
Yes, the autonomy.
Economy of the, yes. So for each time, for example, when we would like to prepare a digital elevation model from the surveying of the pipeline area, we need to go ahead more and more, and we cannot just surveying in the quadrangle area.
Oh, of course, yes. You can use it. You can use the EV or other technologies that can fly more than the EV. But the interesting thing is, for the georeferencing, we use the RTK technology, which is real-time kinematic. In this kind of flight, we don't use that, because as soon as you lost the communication with the radio, because it goes far, you need to use the PPK, which is the post-processing. It's a classical GPS technology. But the EBs and other fixed wing has this technology. So you will process the data later just to make precise pictures. It's very good to do it. It can fly very far and go back. It depends on, or you can take another solution. There are other solutions that can fly farther. What you can do to enhance your image is the payload. Don't use a normal camera, but an oblique camera. You have cameras that have two, they can change the angle. Because the pipeline, if you want to have a good shape of the pipeline, it depends on what you want to do. If you want to say the shape of the pipeline or the DEM around the pipeline, you can use a classical photogrammetry. But if you want a very good shape of, you can do a fly with inclined camera. You have many kinds of camera that have this kind of technology. Otherwise, you make two flies, one in one direction and the other in other direction. So you have two point of view, so you can make a better 3D shaping of the pipeline.
It's the same up, for example, INSAR method that by ascending and descending method.
Yes, for example, yes. But this is only for the parallax aspect. Parallax, so you can make better images. Now they put two cameras that have two angles, one 45, and it takes two pictures in the same time, or it has a very fast camera that makes two pictures. They do this.
It's interesting. Yes.
Yes.
Thank you, Fawzi. It's nice. If there is a question from participant, please don't hesitate.
Don't hesitate.
Question, comment.
Even I don't know. You don't speak Arabic. Even in Arabic.
Even you can speak Italian if you would like.
In Italiano.
Italiano, yes. Anyway, the presentation will be saved on the link for 30 days.
Okay.
So if somebody has a question or later they can provide the question and send to Fawzi as well as to Marco to have it.
Yes.
And it was.
I wanted to stay very technical, excuse me, on the drone aspect, just to put the spotlights on different things. So people maybe later will be, I wanted to know this. Maybe they can send me an email or.
At least myself, because it's actually we need the drone. The more and more use the drone in the surveying and use because largely I have used, for example, in the several projects kinematic GPS, but it's very limited. We can use it in limited area. And the drone allowed us to serving more faster and even more, I think, more precise, provide more precise in somehow. Thank you very much, Fawzi.
You're welcome.
For your time and nice presentation. I invite you also and your colleagues to join us because monthly we have the same seminar which was arranged by the UNESCO chair on coastal geohazard analysis. So it's very interesting for everybody, and you will be welcome to present develop and progress of the project and the new research, and we can learn from you more. And I learned a lot from both of your talk yesterday and today also. So thank you again. And
thank you very much.
If you have not, you don't like to add something, I say bye-bye to you and the other participant.
Thank you. Bye-bye. If you have my email, send me email if you have some questions.
Yes, we keep in touch, surely. We keep in touch. Thank you again.
Thank you.
And give my regards to Stefano and the colleagues in INGV.
Va bene.
Okay.
Grazie. Arrivederci.
Ciao, arrivederci.
Ciao.